Hi, this is part 6 of the Stetson Pinkham Museum Tour. We've had a few new additions in the last year, and the first one right here is a KG9Q. In other words, that's a racing leg, 15 inches. It was made for the standard 15-inch runabouts, which were pretty much obsolete by 1954. By the end of 1954, the ruling race committee ruled that 11-inch transoms were okay, and that's why we went to this engine right here, which is the 40H, which is for 11-inch transom. The engines look the same. They are quite different. This one has a gear-driven magneto, and it has a mechanical fuel pump, AC fuel pump, that works off a cam. The other one uses a pressure tank, but this one actually has a mechanical, like a car, pump that works off of those gears that also operate the magneto. It is quite fast, it goes good, but it's very, very difficult to work on. We tested the engine out. You can see this engine run on the Pine Tree Boating Club's YouTube video website, and it performed very, very well. I got speeds of 46 miles an hour under absolutely ideal conditions when I was through testing it and got it broken in. The next motor is a Lockwood 72T. It was given to me by the club members in the Pine Tree Boating Club. It has taken 2 years to get it running properly. I put it together, it was in parts and pieces, and thanks to Bill Androlitis, who had a lot of the parts that were missing, we were able to get it together, and the difficulties lay in the water pump. The water pump spring is critical in this particular engine, and I finally found a suitable stainless steel spring that would work, that had the right number of coils and the appropriate amount of pressure to make it pump properly, so I've got to run. Again, this one, there are videos of this engine on the Pine Tree Boating Club YouTube site, and it's a very nice running engine. The boat it was running on in that video is a contemporary boat that recommended this engine as the engine. Still got it going? The Lockwood, this 72T has a piston water pump which drives the water up, and it was one of the last engines they used that piston pump on because it really didn't give consistent, adequate cooling at the RPMs that they were talking about. And when the next series came out, which was the Lockwood Chief, they had vacuum pressure systems, which were passive holes in the front of the lower unit and either a hole in the back side of the propeller or just the pull on the back side, like Johnson had a pickup that had on the back side of it a vacuum. In the case of the Lockwood Chief, it had a hollow propeller. That propeller right there is a racing propeller. It's not hollow, and the vacuum of the water rushing past the end right here draws the water out, and the holes in front push it in. But this one has a pump. Intake in the front right here to force water in. The propeller forces water up this, and then this hole in the back side, which is separate, the water going past it draws the water out. It's like a vacuum. So that's vacuum pressure. As I say, Lockwood's system was a little bit different. It had a propeller that had a hole in it on the back side. Okay, the next engines we'll talk about is this little Johnson J25. It's a 1929. It is an extremely good running engine. And for a single cylinder engine, it was the first engine that had a balanced crankshaft. So this engine running on the back of a boat versus like this Wisconsin or an Evinrude rowboat motor or any of the rowboat motors, they did not have a balanced crank, so they vibrate like crazy. This thing is counterweighted on the crankshaft, so the engine at 180 degrees is staying even and balanced, and it vibrates very, very little for a single cylinder engine. This one is a piston pump engine. They didn't change it much from their early water bugs. It's got the same type of lower unit. It's got a piston pump with a spring in it, and it operates very, very well for this RPM of this engine and the way it goes. But this is, as I say, a very, very good running little engine. It starts and runs extremely well, and it's very reliable. And the thing that's interesting about this engine is if you look at the rope plate, it says South Bend. Even though this is a 1929 and the South Bend plant, everything had been moved to the new company in Waukegan, Illinois. And the only thing that has been said about this is they must have made a whole pile of these plates, and since it was a low cost, a low small engine, they just left the original plates on them and didn't bother to change them, even though they were making them in the new plant. This one was made in Waukegan, but it has a South Bend recoil plate, which is accurate because the serial number is here, and it is a 1929 serial number. The next engine we have here is the biggest engine that Johnson made in 1929. It was a four-cylinder V45. It had a one-to-one intake to it, a one-to-one geared intake window, piston, basically a, let me see if I can remember exactly what they did call it. Doesn't have been anyhow. This was the first series of engines to use this kind of porting, which allowed them to turn it up at a lot higher RPM. It allowed the engine to go faster. And the next year they went to a 2-to-1, which made it even more powerful. They got a lot more horsepower out of it as a result of using this rotary valve system rather than just a straight intake and using a 3-port system. This engine runs extremely well, like all of Johnson's. It has a decompressor, which allows you to start the engine relatively easy. In other words, it has a valve in here and allows the compression to escape. And the fact that the spark is being utilized in a non-compressed gas, it allows a stronger spark on the other side. That was the thinking behind it, and I guess it probably works. I don't understand the principles, but my guess is that if in the compressed gases, it's harder for that spark to jump, and that would have occurred over on this side over here. So making it no compression on this side to start it with made the spark intensify on the other side. The ignition system on it is dual coil. It fires opposed cylinders on top and opposed cylinders on bottom. But they noticed when this decompressor was activated that the engine ran extremely well as an alternate firing engine, and that's where they developed their alternate firing twins the next year. This engine, they call it a Seahorse 32, and I asked around about that. I said, what does the 32 mean? Well, 32 horsepower is what they got out of the racing version of this. So they called them all 32s, even though this is only a 26 horsepower engine. It has lots of low-end torque, and it runs very, very well. Very pleased with it. Again, has a pressure vacuum cooling system, and it seems to idle well and run well. Any questions you got, David, you can think of?
No.
No? Okay. All right, the next engine here is a Muncie, 1937 Muncie Gearworks, 6 horsepower, horizontally opposed. I do believe at the same time they had an alternate firing twin of the same horsepower. It's a Neptune. This engine right here runs very, very well. The ignition system, I had it for years and finally found a coil that would work for it, and now it seems to run quite well. It has a pumping system that is a centrifugal impeller, and it runs, it's not a vacuum pressure system, but it's got an impeller which on one side picks up as a vacuum, and on the other side causes pressure and forces the water up into the power head and cools it that way. This engine has some unusual features, even though it's a pretty old design. It has ball bearings at the top and bottom of the crankshaft, and they turn up fairly well. And again, I got something about this V45 that I didn't talk about before. The V45 has solid bearings at top and bottom of the crankshaft, but it has roller bearings on the connecting rods. And Evinrude came out with this in 1928 with this system. In fact, theirs had ball bearing top and bottom and ball bearings and tapered roller bearings in the lower unit. This one just on the connecting rod end of the crankshaft. And Johnson had some real difficulty with understanding how to heat treat. The Evinrudes, run into the failure, but on the Johnsons, they had a great deal of difficulty and a great deal of warranty returns, from what I understand, on the crankshaft because the hardening wasn't done properly. Either they didn't treat it properly or they ground it down so it was too thin. I really don't know too much about it other than this one here, and every one I've ever seen has had the crankshaft replaced. This one, when I was working on it, I could see that it had been changed because there was some welded parts inside.